Good morning, children. Today we are going to see ions, chemical formulae, and their formations. Now, what is an ion? See, as definition, it is a charged particle. Cation is positively charged and anion is negatively charged. Children, you all know metals and non-metals. Yes, few examples of metals: sodium, calcium, potassium. Non-metals: chlorine, fluorine, iodine, sulfur, oxygen, right? So metals and non-metals are two different elements. They combine with each other and we get ionic compounds. So let's see what is an ion. Now see, here you can see the picture of sodium atom. Yes, sodium atom's atomic number is 11. It means electronic configuration: first shell 2 electrons, second shell 8 electrons, and last shell 1 electron. Now shell means, shell is imaginary path for the what revolution of electrons around nucleus. As planets moves around or revolves around sun, same way electrons are revolving around nucleus. Now this is sodium atom. But when electron from the valence shell or outermost shell, when it is get transfer, then we get sodium ion, Na plus ion, and as it is positively charged, it is known as cation. Only one electron is loosened by sodium atom, therefore 1 plus charge is present on sodium ion. You can see electronic configuration: sodium atom is 281, and electronic configuration of sodium ion, that is cation, is 28. Next, chlorine atom. Chlorine atomic number 17, configuration is 287. It means first shell carries 2 electrons, second 8 electrons, and in the outermost shell there are 7 electrons. So chlorine atom accepts 1 electron. It gains 1 electron to complete its octet, and it becomes chloride ion, Cl minus ion. As it is negatively charged particle, it is called anion. You can see electronic configuration of chlorine atom is 287 and chloride ion is 288. So that's the difference between isolated atom and its respective cation or anion. So cation means positive ion and anion is negative ion. Cation is formed from metals. Okay, therefore we say metals are electropositive, and anions are formed from non-metals, and therefore non-metals are electronegative. Okay, so this is the table from your textbook. Here you can see list of cations and anions. Now cations are positively charged and anions are negatively charged. Now see sodium, sodium Na plus, potassium K plus, silver Ag plus, copper Cu plus, right? So one positive charge is present on these metals. Then hydrogen H plus, hydride H minus, means hydrogen is as cation as well as an anion. Chloride Cl minus, bromide Br minus, iodide I minus, means one negative charge is present on these elements. Now polyatomic ions. Now see, polyatomic means more than one or two. More than two atoms are present in these ions. Therefore, they are called polyatomic ions. So NH4 plus charge, OH minus charge, NO3 minus, and HCO3 minus, that is hydrogen carbonate. It is also called bicarbonate. So these are monoatomic ions. Monoatomic means, or monovalent, sorry, they are monovalent means whose valency is 1. Okay, you can see the charges present on each ion is plus charge or minus charge. Now second, Magnesium Mg2 plus, calcium 2 plus, zinc 2 plus, iron 2 plus, copper 2 plus. Oxide O2 minus, sulfide S2 minus, carbonate CO3 2 minus, polyatomic ion, sulfite SO3 2 minus, and sulfate SO4 2 minus. So these are divalent cations and anions. Divalent means whose charge is 2 plus or 2 minus. Now trivalent ions are aluminium Al3 plus, iron Fe3 plus, nitride N3 minus, and polyatomic ion phosphate is PO4 3 minus. Right? Here you can see there are some metals which are having multivalent. They are multivalent, means the copper 1 plus charge is also present and 2 plus is also present. Then what? Iron Fe2 plus as well as Fe3 plus. So these are the different charges present on these metals. Okay, so you have to learn these symbols and the valency or the charges present on them. Now what is the valency? Now see, positive charge present, so 1 plus is the valency. Negative charge, then 1 minus. 1 plus is for metals and minus charge is for non-metals. Now 2 plus means divalent, 2 charges are present. So these are metals and negative charges means non-metals, right? 3 plus, 3 charges are present on aluminium and iron, and negative charges are present on nitride and phosphate because they form anions, negatively charged particles. Okay, you have to learn this for the formation of compound. Let's see how to form different formulae of compound. Now compound, if you'll see, all these are ionic compounds. Ionic compounds are made up of metals and non-metals. Whenever we write compounds, first we write metal and then non-metal. For example, hydrogen chloride. How to form formula? First write down the symbols. What is the symbol of hydrogen? H. Chloride Cl. Okay, capital H for hydrogen and capital C small l for chloride. Now these are the elements. Below that we have written their valencies or the charges. What charge is present? In previous table you must have seen hydrogen is 1 plus, as it is first or the left side, therefore it is metal. Okay, so 1 plus charge. If you are not writing plus or minus, that is also okay. Just write down the number. So 1 plus and chloride is 1 minus. Then cross it. After crossing, whatever you will be getting, that is the correct molecular formula or the compound formula, HCl. Hydrogen sulfide. Now hydrogen capital H and sulfide is capital S. Valency of hydrogen is 1 plus and sulfide is 2 minus. Cross it. So see where the cross is going from hydrogen, it's going to 2 minus, right? So hydrogen H2 and this sulfur S, H2S. Carbon tetrachloride. Now carbon 4. Now see, carbon usually shares the electrons, therefore there is no charge, and chloride 1 minus. After crossing it, we are getting CCl4. Okay, why 4? Because 4 is the valency of carbon. Carbon is tetravalent. So after making the cross, we are getting CCl4. Next, magnesium chloride. So what is the element? Mg, capital M small g, chloride Cl. Valency of magnesium is 2 plus and chloride is 1 minus. After crossing, we get MgCl2. Aluminium oxide, symbol of aluminium is Al, capital A small l. Oxide, oxygen is O. Now valency of aluminium, you have to check in that table, 3 plus and oxide, oxygen is 2 minus. So after crossing, we get Al2O3. See, these numbers you have to write at the base of these elements. Okay, so the height means Al, that 2 number should not have the height of aluminium, right? So these numbers Al 2 at the base and O 3 at the base. This way you have to write. Calcium oxide. Symbol of calcium is Ca, oxide O. Valency of calcium 2 plus, oxygen 2 minus. Now see, after crossing we get Ca2O2. Now these are the same numbers. Therefore they get cancelled, right? Whenever we write formulae, always we write lowest number. Okay. So calcium 2, oxygen 2. This is not a proper way. So that will get cancelled and the formula is calcium oxide. Next example, sodium nitrate. Sodium Na. Nitrate is polyatomic ion, NO3. Okay. So if you will see that table, Na is 1 plus and nitrate is 1 minus. Okay. 1 will get cancelled after crossing. The formula is NaNO3. Calcium hydroxide, symbol of calcium is written Ca. Hydroxide is polyatomic ion, OH. From the table you can check calcium is 2 plus. There are two charges, right? Ca2 plus is written. That charge we are writing here, 2 plus. And OH is 1 minus. So after crossing we get Ca. OH twice. Now see, you cannot write just CaOH twice. You have to take OH in bracket. Why? Because OH is polyatomic ion and that too is common for oxygen as well as hydrogen, right? And therefore for polyatomic ions we use bracket, right? So Ca in bracket, OH twice. Next, sodium carbonate. Symbol for sodium Na. Carbonate polyatomic ion CO3. So from valency you can check Na is 1 plus, CO3 is 2 minus, carbonate is 2 minus. So after crossing we get Na2CO3. Okay, ammonium sulfate. Ammonium NH4 plus, right? So 1 plus is the valency. Sulfate is SO4 2 minus. So 2 minus we have written down. So after crossing, now see NH4 is polyatomic. So the 2 will be common for NH4. You have to take the whole polyatomic ion, that is NH4 in bracket and then twice. Okay. So NH4 twice, SO4. Now there is 1 plus, so we are not writing, we never indicate number 1 here. So as sulfate SO4 is polyatomic, there is no need to take bracket for it. So the formula is NH4 twice SO4. Next, sodium oxide. Symbol of sodium is Na, oxide is O. Charge on Na is 1 plus, oxygen is 2 minus. So after crossing, what do we get? Na2O. Last, aluminium chloride. Capital A, small l, chlorine, for chlorine Cl. Valency of Al, you must have seen Al3 plus, right? So that 3 plus we are writing here. Cl is 1 minus. After crossing, what do we get? AlCl3. So this way you are going to write chemical formulae, right? You have to learn it. For that, what is the basic thing to know? That is the valency, which are the monovalent, divalent and trivalent elements, which are the polyatomic ions. Okay, so the table is very important. You have to learn those that table or the elements. In online class we are going to solve more and more examples. Thank you children. Goodbye.